One of the many challenges confronted in Mini-Urban Challenge is adhering to the right-of-way traffic rules for intersections. This is a priority system which prevents the collision of two EV3 robots that meet each other at an intersection. The basic rule is this: when two EV3 robots confront each other at an intersection, the robot on the left must wait until the robot on the right rounds the corner. Once the robot on the right crosses, the one on the left has permission to do the same. However, teams will be penalized if A. Their robot does not check the intersection for other robots, B. Their robot does not honor the priority system and crosses prematurely, or C. Their robot fails to wait a sufficient amount of time for the other robot to cross and crashes into the other robot. Because it is impossible to have a fail-safe right-of-way system without a unified method among all robots on the mat, the team at Mini-Urban Challenge has developed a standard procedure for adhering to the right-of-way rules. The following flowchart outlines this standard. For instance, let's say we want our robot to take a right turn. Because the streets in the Mini-Urban Challenge city are one-way streets, a right-turning robot will only confront a robot to its left. Therefore, the robot's ultrasonic sensor will scan left. If it detects another robot, it will remain stationary for 6 seconds. Readjust its sensor to the middle, and check again. This, of course, will continue until it no longer detects another object. If no object is detected, the robot will cross the intersection. The same is done if the robot needs to take a left turn. However, there are 2 differences. The first difference is that the ultrasonic sensor must scan right. The second difference is that instead of waiting for an initial 6 seconds after detecting another robot, the robot will wait for the longer period of 12 seconds. This is because a left-turning robot will never have right-of-way priority. For a robot that is going straight, the procedure is the same, except that the ultrasonic sensor will scan both left and right, in that order, and repeat the same routine for left or right turns. The following clip shows 2 EV3 robots conforming to the right-of-way standard. Note that when detecting another robot, the robots will not only readjust their ultrasonic sensors and wait, but back away from the red stopping line. Though seemingly minor, this is an important element in the right-of-way standard, as it prevents collision between 2 robots. And while the exact distance that the robot should back up is not specified, it must be enough to ensure that a potential collision is safely avoided.